So use chemical equations to calculate volumes of gases and vice versa. The concept of amount of substance, the molar volume of gases, and the expression PV is equal to nRT. We measure the amount of substance in mole.
Okay.
So you have to copy this formula. This is amount of substance.
Okay. Doing it.
You have to copy this.
Yeah, done. Copied.
Number of mole is equal to number of particles upon Avogadro constant. So we can use that. All gases occupy the same volume under the same conditions. It's a very important concept in chemistry. And this is something to remember, a very interesting property of gases, that all gases occupy the same volume. All gases occupy the same volume
Okay.
under the same conditions. Now, at room temperature and pressure RTP, the molar gas volume is 24.0. Room temperature and pressure are this values given. At standard temperature pressure, the molar gas volume of any gas is 22.4. Now, these are two important measuring scales. Here, we will use a formula. Volume is equal to N into 24. What is N in this chapter? Small n. Yes, Shahid. What is N in this chapter?
Mole. Oh, sorry, in this one.
Number of moles.
Yeah.
In this chapter, N is the number of moles. Now you have to copy this important sheet.
Yeah.
Have you copied it?
Copying, copying. Okay, copy it all.
So there are two formulas now. There are two formulas now.
Yeah.
Number of moles is equal to volume of gas upon molar gas volume. Now this is another formula. You have to copy this. Have you copied it?
Yep. This can
Now,
also be in cm cube if you multiply it by 1,000, isn't it?
if you want to convert, you should convert both of them. If you want to convert, if you have to convert both of them. 1 meter is equal to 10 decimeter. So it means 1 cubic meter is 1000 decimeter.
Okay.
So these are the two conversions. Copy this also.
M is meters, right? So,
M
okay.
is meter.
Yeah, okay. Okay, done.
Now we have an entry of ideal gas equation. This is a formula used to manage the variables like pressure, volume. The ideal gas equation, PV is equal to nRT, P is equal to pressure, V is equal to volume, N is the amount of substance in moles, R is the gas constant which is given in the data booklet as 8.31, T is equal to temperature in Kelvin. This is called ideal gas equation. Now you have to copy this screen.
Okay. For the R and the gas constant, is it always the exact same for
R
every
is
single?
called the gas constant.
Okay, but like, is it always the same?
This is a constant value for all calculation. R is the same. For all calculations, the value of R would be the same. Now, I'm putting an example. We are doing quick examples here because we can't do actually long examples in our notes because I want the notes to be precise. But obviously, you must have noticed that this is a numerical chapter. This chapter is numerical. That is why I kept it in the end because it doesn't take much time. But in terms of questions, it has no limit. You can keep on doing the questions and there's no limit on how many questions you want. Now, calculating the volume of a gas, calculate the volume occupied by 0.781 mole of oxygen at a pressure of 220 kilopascal and a temperature of 21 degree.
Okay.
First, okay. Let me recall for you another set of unit conversions first, because these are the unit conversions. Copy these unit conversions also.
Okay. Done.
Now, copy this example. Look at this working. Calculate the volume of a gas. Calculate the volume occupied by 0.781 mole of oxygen at a pressure of 220 kilopascal and a temperature of 21 degrees centigrade. First, you have to have you copied the equation, the example, Shahid?
This one, the 0.78 mole.
Have you copied it, right? Now look at the answer.
No, I
Step
haven't.
one,
No.
which is, sorry, did you say
I've-
something?
No, nothing.
Okay, so I've rearranged the equation. Calculate the volume the oxygen occupies. Pressure, I have converted to Pascal. Moles, R value. Temperature converted to Kelvin. Then put it in the equation. This is a solved example. So you have to copy the working for reference.
Okay. Okay, done.
You have copied it?
Yes.
Oh, so quick, Shahid.
Yeah.
Then calculate percentage yield and percentage atom economies. I had actually given you the percentage yield formula before already. So the atom economy is a unique name, and the industrial processes using chemical equation and experimental results. You have to see this formula. Atom economy is equal to molar mass of the desired product upon sum of the molar masses of all the products. You have to copy this screen now.
Okay. Yeah, done.
Atom economy, this is a new name. Percentage yield, we have already copied. To determine a formula or confirm an equation by experiment, including evaluation of the data. This is not something to discuss in theory. This is actually to determine the formula using the data and establishing the ratio. You can find a formula and you can also confirm the position of the formula. Now you have to copy this screen.
Okay. Okay, copied.
For practical one, measurement of the molar volume of a gas. Practicals we won't be discussing here. It's not part of unit 1. But whenever practical comes, I had shared with you some videos. Hopefully, when you get the college and when you get to school, they will be showing you some lab work. Actually, this is something which comes from the lab. In EDEXCEL, this unit 3 needs some practical knowledge. So you have to copy this screen.
Okay.
Molar volume of gas.
Okay.
Let me share a video link with you, and you should look at it after the class.
Okay, sure.
This is basically a laboratory exercise that how you can find the volume of a gas in a laboratory. They have mentioned some other experiments also. This is only for a syllabus cover up, because this is something which is first of all should be done in a laboratory. If laboratory work is not there, then the last thing is obviously video support. I'm putting this question. This question is about iron 2 salt. What is the percentage by mass of iron in anhydrous? Anhydrous means, what is anhydrous meaning? Which does not contain water. Anhydrous copper iron 2 sulfate to 3 significant figures. Do you have a periodic table which I sent to you? Can you open it? Sher, can you hear me? Sher, can you hear me?
Yes, I can hear you.
So please open the periodic table which I had posted to you.
Yeah, Fe is 55.8.
Okay, you need to work with me. Fe is
55.8. Oxygen, we can just write it 16 plus.
sulfur.
It says 16 times. Yeah, 32. Oxygen 16 times 4, which is 64. Yeah.
So can you sum up them?
Yeah, this would be 151.8. So basically 152 to 3 significant figures.
No, do not round it. It's chemistry, not physics.
No,
Do
it
not
says
round it until you
3
get the
significant
final
figures
answer.
though. Okay.
First, solve it. Do the working with me.
This is 36.8%.
It's now very close to option
Okay.
number C.
C. Yeah.
Describe a chemical test and the expected result to show that sulfate ions are present in a solution of iron 2 sulfate in water.
Okay. This would be no, that would be for copper sulfate. No, okay. Sulfate ions or was it, no, that wasn't it. A barium sulfate thing? No, that was
So he's
something
not
else.
talking about barium sulfate. He's talking
Hold
about
on.
iron 2 sulfate.
Yeah, sorry, it was barium chloride that you had, and it gives a white precipitate.
White precipitate. Very good memory, but how should I start? How should I write the answer?
You should start it by saying first, add would you add the compound into the
Your
a barium
barium
chloride, or would you
sulfate
add,
idea is fine, but how I reach barium sulfate? Because it is iron 2 sulfate, FeSO4.
right?
So if I
So
start with an acid,
would it not displace it?
acid it's like a test, not test for sulfate. Can you look? I'm trying. Let me find the thing. I think I had shared with you the data booklet. I think so. Have I shared with you? Data booklet is there.
Which one is it? This one,
If you
the
open the
appendix 9.
if you open
Right.
the chat,
Yeah. Indicators. No, that's indicators. Okay. Standard. No, where is it? No, there's nothing for chemical test for ions
I
here.
think it was a test I had mentioned here, but
No,
test
there's no
of
test. There's no test for
yeah,
ions.
I think I have not forwarded you now. But this is a memory game. This is a memory setup, and
Okay. Think. Yeah.
so you need to remember that you have to acidify the solution and then add barium chloride. It will
Okay.
replace barium chloride. Barium will replace iron. And do you remember reactivity series?
Yes.
So barium will replace iron and it will become barium sulfate. And barium sulfate is not soluble. As you said, it will give you white PPT.
Okay.
Okay. More salt is another compound containing iron 2 ions. It's a hydrated form. What is the molar mass in gram per mole of more salt? Just a minute. You just start solving it.
Okay.
Did you get the answer?
1 second, just doing it. This should be 312.
312.
Yep.
Well, your meaning 312 is B.
Yes, B.
Oh, look.
12 plus 16, then that is 32 plus 16 times 4, all multiplied by 2 plus 55.8, then added to 4 plus
Just check the
14, all
calculation again,
multiplied by
because
2.
I don't have an answer for this. I'm checking it, but you have to just double check.
Yeah, it is 312. I triple checked actually. I was getting the wrong
It
answer, but
says
then I
that
found
what
out.
is the molar mass of more salt? Did you add water also?
The at the end, right? Yes, I did.
To 18.
That's 28 at the end.
Sorry,
It's 28 at the end, right? So I added that.
but there are 6 water molecules also, right?
Yeah, so that's 28. If
Okay,
you subtract that, you get if you subtract, you get a 284, which would be D,
why are you subtracting?
because if no, you're saying if we remove that the water molecules, right?
But you need to find all of it. Okay. Okay, fine. Then we'll keep it up to here. I can check it and update you accordingly. For the
Okay.
time being, it's okay. And we will inshallah continue this in our next class. And as I advise you, you should try to get topical books, because you know it will be advantageous for you to solve on the book. Digital files are there, but they can't replace the paperwork.
Okay.
Anyways, we'll inshallah discuss in the next class. Thank you.
Okay, Lafis.